Hey everyone. So hopefully after the last video, you all have slightly more of an idea of the intuition that goes into solving equations through the type of scale analogy we discussed. And at the end of that video, we also touched on how we can interpret this and apply it to solving equations with pronumerals on both sides. And this is what I want to continue to touch on today. Now, I have an example here, which is 7t plus 4 equals 5t plus 10. Now, what I'm going to do here is I'm going to take that same analogy. We're going to draw up our scale. It's going to look a little bit more busy and kind of full on because I have my numbers here are a lot bigger. But you'll be able to see that the intuition from last video will hopefully carry over into dealing with even bigger numbers here. So I have here 7t plus 4, and we'll use the same marble bag analogy as we did before. And what I want to do is I want to treat my t here, for example, my variable, my pronumeral, my unknown. I want to think of this as the bags, right? We'll keep going with this marble bag analogy. So if I have, for example, 1, 2, 3, 4, 5, 6, 7. So let's call this T. So each T is a bag or a box of marbles here. And I have another 4 marbles left. 4. I've drawn that here. And on this one, I'm going to have 1, 2, 3 boxes or bags of marbles, 4, 5. So I have 5 in total, and I have another 10 marbles left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I want to try to systematically solve this equation. And I have a lot more happening, right? I've got pronumerals on both sides. So I want to use the same logic from the previous video to try to balance this thing out and give me the value of, or the amount of marbles, if we still want to go with that analogy, in one of these boxes. So in other words, I want to find what t is going to be equal to. Now, let me rewrite my equation down the bottom. So I have 7t plus 4 equals 5t plus 10. Now, what do I want to do? Well, I want to systematically, little by little, get rid of things from either side of the scale, but I want to make sure it's balanced, right? That's this whole idea that I kept banging on about in the previous series about what we do to one side, we do to the other. Because it's an equation, my left-hand side is equal to my right-hand side. So whatever operation I do to one side, that's going to unbalance the scale. So I want to do the same thing to the other side to get it back to a stable position. So what I want to do to start off with, let's remove 1, 2, 3, 4 marbles from the left-hand side. So to show you mathematically what I've done there, I'm removing 4 marbles from this side, and I want to balance the other side, because if I don't, my 2 scales are going to get really unbalanced. So I want to go 1, 2, 3, 4. I'm getting rid of 4 marbles from each to balance this out. And now what I have left is on the left-hand side, 4 minus 4 gives me 0. So my negative 4 cancels out with my positive 4. So I get 7t plus 0, which just gives me 7t. And on the right-hand side, 10 minus 4 gives me 6. And you can see I have 6 marbles left. So that makes sense. So I have 5t plus 6. Now what do I want to do? Well, I want to just find how many marbles are in one of my boxes or bags here. So what I'm going to do is I want to get rid of, I have more bags on this side than this side. So I want to take off all of these so I can just get left with my marbles here. And in doing so, I'm going to get a couple left over on my left-hand side. And then from there, I can very easily go about solving the equation at the end. So what I want to do is I want to subtract 1, 2, 3, 4, 5 boxes from this scale. So I want to take away 5t from this side. So I have positive 5t here. So if I take away 5t from that, that leaves me with 0 lots of t, 0 bags here. And what I do to one side, I want to do to the other side. So I'm going to take away 5 from here. 2, 3, 4, and 5. So I am taking away 5t from both. What do I get left with? Well, I have 2 boxes here. So I have 2t and I have 5t minus 5t. Once again, that kills this off. I have 0 boxes, as you can see, and I have 6 marbles left. So I get 6 on this right-hand side. And now what I want to do is, well, I want to figure out how many marbles are in the 2 boxes. In other words, I have 2 lots of these set of marbles. What number multiplies by 2 to give me 6? I can figure that out by doing this opposite operation, dividing my group on the right into 2 groups. I'm doing the opposite operation. So I'm dividing by 2, I'm dividing by 2. So I get, when I divide that into 2, that therefore in each of these boxes, there will be 3 marbles. And let me color code that so you can see that here as well. Now in this box, I have 3 marbles. It balances out perfectly. And a lot of you, if you're comfortable with the equation stuff we were doing from the last video series, hopefully this is nothing new. So I have the amount of marbles here is going to be 3 in each. My unknown variable that I've solved using this scale analogy, the same one from the last video, gets me to systematically solve to get my answer. Now let's look at a slightly trickier example, and this is one where the analogy it's a bit harder to visualize. It drops off a little bit because we're dealing with negatives here. I want to figure out what this particular equation is. So what I want to do is, it's hard for me to sort of visualize this, but I'm just going to try to just give you guys the idea. Draw my little dodgy scale here, just to give you guys an idea of how we could possibly work with negatives here. Now, I have 2u here. Now let me draw this in a darker color actually. So these are my 2 boxes of u. I have 1, 2, 3, 4, 5, 6, 7. Now I want to try to think about, what does this mean by negative 20? And what essentially what does that mean for our imbalance here? Now, I have another tab open here. Now, this is a little like, they call it a pan balance. This is to hopefully give you some of the intuition. So what I have here, my scales are balanced, and I want to just show you, because I have essentially 0 marbles over on this side, but I have -20 here. Now, I can't really visualize -20, can I? But I can sort of show you what I mean when I end up I want to show you what I mean when I end up balancing this thing out. So say I put in to my right hand side, just to really mimic the equation, I put -20. Notice my thing gets imbalanced, right? And if I have -20 on my right hand side, that's the equivalent of if I just had 20 on my left hand side and nothing on my right hand side. Let me show you what I mean by that. On my left hand side, if I put 20 here, notice my scale is at the same position as it was before. It's favored in the left hand side. So what I can do here is I can say that because this is -20, that would be the same as just drawing 20 marbles here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And let's actually look at the maths, what I've actually done here. I started off with 2u equals 7u minus 20. And what did I do to balance this out? Well, I essentially did the opposite of this operation on this side. So I wound up with, I said that this was the same as if I added 20 to both sides. And on my left, now I get 2u plus 20. And I get 7u. And minus 20 plus 20, well, those two just cancel each other out to give me 0. So I'm just left with 7u on my right-hand side. Or in other words, my 7 boxes of marbles on the right-hand side. And now I want to balance out the boxes, because from our last example, if you remember, I have more boxes on this side than I do on this side. So I can take off these two and then just balance out the rest on this side. So if I subtracted these two boxes, so I minus 2u from here, well, that unbalances this, right? So I want to do the same here to leave me with a nice even balance. So I've minused effectively 2u from each side. And what do I get left with? Well, on my left-hand side, 2u minus 2u, I don't know what u is, but I know that it's the same number. So 2 lots of a number minus 2 lots of the same number gives me 0. And on my right-hand side, I can use what I know from algebra, which is 7u minus 2u. Well, that just gives me 5u. And what do I have on my left-hand side? Well, I just have 20 here. And now I want to figure out, well, how many. I have 20 marbles on my left-hand side, and I have 5 boxes on my right-hand side full of marbles. I want to balance this out again. And what we remember from solving equations, now we get to our last point, and from here you can just say, well, what times is by 5 to give me 20? Well, we can find that by doing the opposite operation, by dividing both sides by 5. And if you know your times tables, you'll know that 4 multiplies by 5 to give me u. And we can actually check this once again by substituting it back into the equation. Now, I'll let you guys do that on your own. And we can either write this as 4 equals u or u equals 4. It's the exact same thing. And let's actually look at what we did in these first two examples and apply this to the idea of solving systematically, which we know by now if you've watched the previous video series or if you've done this already in year 7 or the equivalent year in another country. If you look at what we actually did, we are still solving systematically here. I'm adding 4 on my left-hand side. I have a plus 4. So I'm going to do the opposite operation, the inverse operation to get rid of the 4. So the opposite of adding 4 is subtracting 4. I'm doing this to both sides. Nothing different from what we've done before in terms of solving systematically. And now when I wind up with this, well, I want to group my t's together on one side. I want to find out, having these on both sides doesn't really help me. I want to find out what t is at the end of the day. I want to strip this down to have t on its own. So algebra tells us that I can do operations with like terms. So I have positive 5t on my right-hand side. I can undo this by doing the opposite, by taking minus 5t. And that gives me 2t on my left-hand side once I've collected the like terms. And I just get left with 0 plus 6 on the right-hand side. I just get 6. And then from here, I can solve it by inspection or just by doing the opposite, by dividing. I've kind of done the same thing here, guys, because I've rewritten this and I've done the same thing, right? What I do to one side, I do to the other side. So I've added 20 to both sides to just give me a positive 20. That's easier to work with than a negative 20. And hopefully that pan balance visualization gave you an idea about some of the intuition. But what I got here once I did that was just 2u plus 20 equals 7u. And then I wanted to group the like terms again. I want all these u's, these unknown pronumerals together because algebra tells me that I can subtract and add like terms. And once I do that, I subtract my like terms to give me 5u, and then I just have my regular number left. And all I do from here is now I can just do the opposite operation. I'm timesing by 5 here. I'm doing u times 5. So I can divide by 5 to give me what u is. Now, keeping all of this in mind, now that hopefully we understand the intuition with the scales and how this is pretty much just solving equations systematically, let's apply this to one more example. And now we can hopefully, now that we're comfortable with the intuition, we can just work through this systematically, which ends up being a lot more quick and efficient. So, what do I want to do here? Well, the essence of what we've been doing so far is we wanted to group my integers, my whole numbers, and we also wanted to group my algebraic terms, my terms with the pronumeral in them. And I can do this in a step-by-step solving systematically way. What we've been drilling completely for like videos upon videos in our previous video series on year 7 equations. Now, I'm going to work through this a little quicker. I have 6x plus 4 equals 22 minus 3x. Well, I can undo this adding of 4 by subtracting 4 from both sides. Remember, I want to keep this scale balanced. Once I do this, I have 0. Here, 4 minus 4 gives me 0. 22 minus 4 gives me 18. So let me write my next line of working in my solving equations systematically. So 22 minus 4 gives me 18 minus 3x. And now I want to get like I mentioned before, my algebraic terms together. So 6x is equal to 18 minus 3x. So I can just do the opposite. I'm minusing 3x from 18 here. So if I add 3x, that will show me what 6x was before we minused 3x from it. Guys, it's the same ideas we've been talking about. As long as we understand the idea of solving systematically, and now hopefully we have the intuition for working with pronumerals on both sides through our scale analogy, this idea of balancing the scales, it opens up these questions. They become a lot easier to work with. And now here, minus 3x plus 3x, those cancel out to give me 0. And algebra tells me I can add my like terms. 6x plus 3x gives me 9x equals 18. And I'm on the home stretch now. What number multiplies by 9 to give me 18? Well, I can figure that out by just dividing both sides by 9. We have a multiplication happening here. So dividing by 9 will give me my unknown variable x. It will give me my x on its own. So dividing both sides by 9, I get that x equals 2. And we know that's true because 9 times 2 gives me 18. So that is how we can bring everything together and start working on solving equations with pronumerals on both sides in a nice systematic way. The same ideas ring true, but I just wanted to give you these examples, these ideas of scales, just to hopefully help you with the intuition. I know it's a little harder to visualize when we have negatives here. Can't really have negative marbles, but the ideas still reign true. And we can use these techniques to work with solving these types of equations. But thank you so much for joining me, guys, and I'll see you in the next video.